All right, good morning, pre-calc students. Hope you had a great weekend and are ready to go with our P7 notes. If you still need to get them pulled in from Google Drive, go ahead and push pause and do that. But we are going to do these three problems on the quick review, number 1, number 2, and number 5. Go ahead and solve those. Football game's on in the other room, so if you hear yelling or something, it's probably okay. It's probably just a good play or a bad play. Alright, I'm going to go ahead and start. If you're not ready, feel free to push pause. So solving number 1, we subtract 1. That gives me negative 4 is less than 2x, which is less than 8, and divide by 2. So divided by a positive number, the sign stays the same. We're looking at numbers from negative 2 up to 4. If I were to graph that, that's talking about the numbers between negative 2 and 4. It's a compound inequality that is an and. So it's talking about the overlap of x is less than 4 and x is greater than negative 2. When you solve number 2, if the absolute value could equal 3, that means that this 2x plus 1 either equaled 3 or it was negative 3. So as soon as our absolute value is by itself, we split it and we solve those two separate equations. So 2x equals 2 and x equals 1. 2x equals negative 4 and x equals negative 2. But always a good idea, especially with absolute value or quadratics or something other than just a simple linear equation, always a good idea to check it and make sure it works. In this case, both of those two solutions work. On this last one, we had to combine the fractions. So the first thought process I want to have is, what would my common denominator be? And that's x times x plus 1, or x squared plus x if we wanted to distribute, but I'm more likely not to. Which means over here we already have an x plus 1, so I need to multiply the top and the bottom by x. And over here I already have an x, so I need to multiply the top and the bottom by x plus 1. Then when I do that, it leaves me with x squared plus, and I'm going to have to distribute the x plus 2 times the x plus 1. So when I distribute, I get x squared plus 1x plus 2x. So 1x plus 2x plus 2. And I can group my 2x squareds together, so I have 2x squared plus 3x plus 2. All over x times x plus 1, or all over x squared plus x. Good practice of some algebra skills that we're going to continue to use. We're moving today into solving inequalities algebraically and graphically. I'm going to look at some review things from advanced algebra and also a few new things as well. Alright, this is one of the review things, that's solving absolute value inequalities. And there's two different ways we need to look at if my absolute value is set up less than a number and if my absolute value is set up greater than a number. Let me start with less than. If I look at this particular example, the absolute value of x is less than 3. If we're thinking about what numbers that's true for, it would be true for 0, the absolute value, that's less than 3, and 1, and 2, and negative 1, and negative 2, and 2.5, and 2.6, and 2.9, but not for 3. And so we can kind of see that this is happening to be true for all of these numbers here, And on this side, less than 3, right? Less than 3, less than 3. The absolute value is less than 3. So if I would pick negative 4, the absolute value of negative 4 is 4, which is bigger than 3. So it stops right here at 3. So when I'm talking about the absolute value of x is less than 3, I'm talking about the numbers in between negative 3 and 3. And that's just a really important thing to be able to connect. That the absolute value of x is less than 3 is talking about the numbers in between those. And in between those is talking about an AND graph, a compound inequality where there's overlap. And it splits this way. It says we want numbers starting at negative 3 and going all the way to 3. So every time we're splitting apart an absolute value because we need to solve it, we need to say, okay, if it started like this, the absolute value of something is less than a, then I split it and I get rid of my absolute value by writing it this way. Negative a is less than whatever was in the absolute value, which is less than a. And we're going to do a specific example of this here in just a little bit. Let's do one with greater than. So the absolute value of x is greater than 3. Here's 0, here's 3, here's negative 3. Let's talk about numbers that would make that true. 4, and 5, and 6, and 7, and 8, and everything bigger. And 3.1, but not 3, right? All right, so this is true for every number that's bigger than 3. Yep, that's true, it is. And it's also true, let's see, for negative 4. Because negative 4, the absolute value of negative 4 is 4, and 4 is bigger than 3. So negative 5 and negative 6 and everything this direction as well, but not in between them. And so when I look at this graph, I see another compound inequality, but I see a compound inequality that is an OR. And if I wanted to rewrite this as without absolute value, I would have to split it into these two separate parts. I would need to say, well, x is smaller than negative 3 or x is greater than 3. And that is going to happen every time. So every time you're solving an absolute value where it is greater than a number, then you can get rid of that absolute value and solve that inequality by saying this. What's inside your absolute value can either be less than the negative or greater than the positive. All right, so somehow, and we can talk about strategies another time, you need to figure out how you're going to remember that less thans always split this way and greater thans always split this way. You know, maybe less than is compact, smaller, and greater than, there's more of them, you're duplicating it. I don't know, come up with some strategy to be able to remember that, to key it in your mind. And here's an actual example. So the absolute value of x plus 3 is less than 5. So your immediate thought process must be something like this. I see absolute value is less than. If absolute value is less than, then I need to get rid of the absolute value by splitting it. This is talking about numbers in between negative 5 and 5 because it said less than. So my first line is this. Negative 5 is less than x plus 3, which is less than 5. That's how I split it. Now I just use my algebra skills to solve it. Negative 8 is less than x is less than 2. This is how we would solve it. If we were only asked to solve it, that's what you would do. If you were asked to graph it, you'd put it on your number line, open circles, and shade between negative 8 and 2. Oh yeah, there it is, an interval notation, right? Are you remembering that? How about solving this one? It says the absolute value of 3x minus 2 is greater than or equal to 5. So again, thought process. I see absolute value, I see greater than. Absolute value greater than. So I know I need to split it. Greater than, talking about numbers bigger than 5 and smaller than -5. It doesn't matter which way you order these, so if there's one way that makes more sense to you, feel free to do that. I'm going to do less than or equal to -5 or greater than or equal to +5. That's your first line. You have to split it that way, then you start solving it. So we add 2. 3x is less than or equal to -3. We're dividing by a +3, so x is less than or equal to -1. Add 2. And divide by 3. X is greater than or equal to 7/3. This is how we solve it. It's an OR graph. If I were to graph it, I would just graph these two individual pieces. Here's my -1, solid dot on -1 because it's part of the solution, and shade it less than. And let's see, 7/3, 6/3 would be 2, so it's a little bit bigger than 2. Solid circle there on my 7/3 and shaded bigger. And again, that's if they ask you to graph. This one didn't particularly say so. All right, so now we're going to go into solving quadratic inequalities. And in order to do that, we need to be practiced up on our factoring. So go ahead and push pause and practice.